This is going to be video 1.100, and it's going to be an introduction to isometries. So the Greek word iso is just some etymology for you. Let's see that in different color. Let's see that in green. Greek. Iso means same. Metry means measure. So an isometry is something where we have some kind of object and we come up with another object with the same measure. So isometries preserve shape and distance. So shape and size, in other words. Our formal definition of isometry, which most of the stuff with isometries I'm going to do is going to be informal. So the definition of isometry it is a transformation is a isometry if it is a function we'll call it a function t from P to P. I forgot to explain up here. We'll say let P be the Euclidean plane. So it's just some kind of function that's going from the plane to the plane, provided that for any points A and B, AB equals the transformation of A and the transformation of B. So this is just saying that any two isometries form another isometry, which means any number of isometries still form another isometry. Let's go over some notation. We'll do that in orange. We'll say we write A prime equals T of A. So we aren't going to be writing down this T notation too much. And we also write B prime equals T of B. So if T, this transformation, is an isometry, we have AB equals A prime B prime. And then I want to go over the 4 types of isometries. Say there are 4 types of isometries. Let me do each of these in a different color. We'll do a dark green one. First one is translation. I don't like that color. It may not show up well on some of your all's screens. We'll do this one, translation. Let's do one in pink. Let's see, we have rotations. We'll do one in blue. That'll be reflection. And we can do one in white. We'll say an identity. And we'll go over each of these real quick. So a translation is when each point is moved a fixed distance and direction. Oh, I should note that this is also called a glide sometimes. People will call this a glide. I don't like referring to it as that. That's just not something I'm used to. But it's not wrong, it's not right. It's just something people do. So, example. Say we have some shape here. We'll move it here, and we would come up with the same exact shape to the best of my ability to draw it, which that looks a little bit thinner, but we'll pretend that's the same. So that's a translation. We can have a rotation, which is when we have, let's start out with, we'll do a square with a little nub. A rotation is when something moves kind of in a circle around a fixed point. So, rotation here, if we moved it this direction, this little nub would be out here. We'd have slightly longer there, shorter end here, and that would be a rotation. A reflection goes across. A reflection is like a mirror. So, if I have a shape like this, and I want to reflect it across this line, it would look like this. So it's a reflection, and then identity is, that's the most obvious one. It just sends every point to itself. So it's going to be a little bit harder to draw. So let's say I have, we'll just do a basic square. It would just send each point in that square to itself. That doesn't show up very well on this screen. Anyways, if it doesn't show up inside your screens, there is a white square inside the teal box. Those are our 4 types of isometries, and like I said, all proofs here will be informal. Let me write that down for anyone who's not watching the video. All isometry proofs will be informal. And I didn't even give a formal definition for most of these, so the proofs would have to be informal.